After looking at the characteristics of looking with ultraviolet light at minerals, we now want to turn our attention to just the iron compounds. And we've already talked about one of these iron compounds. That was the mirrored pyrite, iron pyrite. But what people don't understand is it doesn't always take this form. So we want to look at some various examples of pyrite and show you what they look like. This sample is iron pyrite. It's different in that the cubes have a different formation and they don't have that mirrored appearance. So each crystal, when they form, has unique properties that make it turn out that way. This one is in contrast with quartz, and very often you'll find pyrite with quartz. When the early miners went out, they were fooled with pyrite. That's why they call it fool's gold. Some of them brought back sacks and sacks of fool's gold, and they were fooled because it's iron pyrite, not gold. These two samples are samples of Utah pyrite. Not quite. This is very close to mirrored pyrite, but you can see this one doesn't have the cube shape. It's just a flat surface. So pyrite doesn't have to make cubes. But if you see cubes like this, you know that it's pyrite. So that's one of the characteristics, again, is the crystal shape sometimes lend us to identifying what you have. So be aware of that. Here is one other sample of pyrite, and it's hexagonal and octagonal crystals. They're not cubes, but it's still iron pyrite. But the cubes were formed in some cases under different characteristics, different temperatures, different locales. This one came out of a very high pressure, high temperature volcanic area. So its crystals form differently than the cubes that you would find. Another characteristic of pyrite is sometimes it doesn't form cubes or octagonal things. It sometimes makes spindles. These are spindles of pyrite on a flat surface, and this is from Russia. It's very rare that they just splattered out like they had a little explosion. But what happened is there was a crack in the rock, and this filled in those cracks with pyrite. So pyrite is one of those intrusive materials that happens around anytime you have magma or volcanic rocks. So the quartz in here is volcanic in nature, and the cracks were filled in with pyrite as a result. This is a very unique type of iron. This is iron. It's not magnetic, though. You can put a magnet on it, it won't hold to it. But this is what they call razor hematite. These are very sharp. If you were to run your finger across them, it would cut you. And that's why I'm holding this on the edge, because each one of these surfaces are razor sharp. That's where it got its name from, razor sharp hematite. Hematite is a nice name for iron ore. One of the things that we need to know about iron ore is that it can make very sharp points like that, or it can make things like this, which are bubbles. These are called botuloidal hematite. It's bubbles. It's a very beautiful material. But again, it is not magnetic. Iron is great, but remember, each one of these compounds vary in the amount of iron that's in them. For instance, this might only be 70% iron to make this. But some of the things like magnetite, which we have mentioned earlier, is 95% iron. This is magnetite. It gets its name because a piece of magnet holds tight to the mineral. So magnetite gets its name because of what magnets do to it. It itself is not a magnet, but magnets hold tight to it. Magnetite comes from Utah. In fact, our county, Iron County, was named after magnetite because they got all the iron from it. And the iron was shipped to Provo, and U.S. Steel made steel from the iron that they got down there. So there's a great history in Iron County, down by Cedar City, where magnetite comes from. Magnetite is kind of a rare element in the fact that not all iron is that pure. To get one that's 95% pure means you don't have to process it as much. And so it was really a valuable ore. And it had a lot to do with the early economic development in Utah. This also is magnetite, much different. It looks like it's just little pieces of spider web, but it's magnetite. It holds it to it. And so that's really an important feature. The magnetite can look different in many different forms. This is just going into the rock and intruding into it. This sample is from over in Cache Valley at Mineral Point. It is called specular hematite. Remember, hematite is iron ore. So this is iron ore. This is a piece that has been cut. And you can see the kind of shine. What this is little flakes of iron glued together. And this would run about 60% iron. Not a great source of iron to mine economically. But nonetheless, it's a mineral and it has a name and very unique characteristics because it's little flakes glued together. This is another example of iron. It looks like a little thumb or finger. This is marcasite. Marcasite is, again, a way that the crystals of iron grew like you would expect a stalactite or stalagmite to make it. And so you would see this probably hanging from the ceiling, and you would see little droplets of iron coming out of the water. So this is marcasite. And again, most iron ores have sulfur in them. And speaking of sulfur, one of the characteristics of some of our minerals is they have smell. And so if you were to go to a refinery, you might smell this mineral. This is sulfur. Sulfur has a unique characteristic in it that it has a smell. Most minerals don't smell. But if it contains sulfur, pyrite, some of the iron, and you refine them or heat them up, you get this odor of sulfur. So that's a unique characteristic that we didn't talk about earlier. One more characteristic that we didn't talk about is this one here. This is called halite. Very famous in Utah because it's salt. It comes from the Great Salt Lake. Its unique characteristic is it has taste. It's salty. Now, I want you to know I sterilized this before I licked it. I don't have the courage to lick it after 5,000 other people did. But this is an example of salt, which comes from the Great Salt Lake. And by the way, a lot of people don't understand that the largest mine in the United States is not Kennecott, Rio Tinto, or any of the other big copper mines in Arizona. It is the Great Salt Lake. It's 50 miles by 70 miles. And they do mine salt, and they also mine sodium and chlorine, a lot of trace minerals besides those. So realize that in Utah, it's a boon and an economic thing to have something that tastes and comes from a great big mine. Okay, one of the other characteristics we haven't talked a lot about is color. This is one of the easiest ways to identify copper, is by the color of the blue and the greens. The malachite is green, the azurite is blue. But when we talk about it later, we'll find out that sometimes it may indicate what the copper is, but it doesn't necessarily mean it, because some things can be green and not be copper, or blue and not be copper. But this is a good example. This came from down in St. George, from the Apex mine. And this mine is famous for this bright colored azurite and malachite. This is another unique characteristic of iron. Iron sometimes alloys with other minerals. In this case, you have this orange-colored or yellow-colored material. That's sphalerite, zinc. The outside, which is kind of brassy-colored, is all iron pyrite. And the dark stuff in the middle is hematite. So you have three minerals alloying together, and it makes a very beautiful pattern. So you have sphalerite, which is zinc, hematite, which is iron, and iron pyrite, which is fool's gold. So realize that many times you'll see minerals in combinations with each other. We wanted to end our program today with a special feature. We have a 285-pound nugget of magnetite. And again, we want to verify that this is magnetite. So we're going to take our magnet, put it on there, and it holds tight to it. The unique feature about this particular piece of magnetite is you very seldom find pure nuggets of a mineral held together. Now, if this was gold, we could all retire and have a good time, but it's not gold. But it is an unusual feature to have 285-pound nugget of magnetite just all together and pure. Most of the magnetite is in layers or seams. This one was formed individually and was laying in a bed of rock that was not magnetic or magnetite. So this is really an important feature, to realize that sometimes minerals form in huge crystals or nuggets. And so that's unique about it. Again, all iron mines would like to be 95% pure iron. So it is really a unique feature. And it has a lot of power to it. Now, thinking about that, we've talked about everything on the earth. Now I want to talk about one more that's not of this earth. These two little samples right here are extraterrestrial objects, better known as meteorites. These are iron meteorites. Where do they come from? Outer space somewhere. Most of them have an origin of the asteroids, but not all of them do. They come from far reaches of our universe. And so whenever you see a shooting star at night, that's one of these things entering our atmosphere. Most of them burn up completely before they hit the earth. But as the dinosaurs found out, not all of these meteorites or asteroids burn up before they hit the earth. And so these are another way that we get minerals on the earth, is from outer space. So now, having said that, I want you to think about some of the things we've talked about today. I want you to think about Iron County, Cedar City, magnetite. How did they get there? What was the history of this? What is the history of mining in Utah? What are some of the characteristics of mineral? What minerals would you like to go out and collect? We are blessed in Utah because we don't have a lot of trees. If you would look at your feet as you're hiking around in Utah, you're going to see minerals that you've never seen, that you wouldn't see if you're on the East Coast where everything is covered with foliage. So we are blessed having lots of minerals that you can go out and hunt for by yourself. Have a great day.